Earth's atmosphere is to Earth as the skin of an apple is to an apple.
That's what I'm saying.
We don't have much air.
We are in danger. First of all, is the sky blue?
Yes.
Okay. Well, at least we got that out.
Does it look blue to you?
It does.
Fine. That's what we're about to talk about.
All right.
Okay. The explanation is actually simple. It just takes a little while to explain.
Okay.
That's all.
All right.
So, we have an atmosphere.
Okay.
We all know this.
Yes, we do.
Okay. It's composed primarily of nitrogen.
Okay.
It's 78% nitrogen, it's 21% oxygen, and a few percent other, carbon dioxide, this sort of thing. Mixed in there are particles of like pollen and dust and sand from sandstorms and pollution and smog. And so
Particulates.
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 Okay. Now, light comes from the sun. White light. People say the sun is yellow. It's white.
Right.
Okay.
Exactly.
You've seen the sun in the middle of the day. It's white.
It is white.
Okay. That's the proper color of the sun in the middle of the day. You may remember that white light is composed of colors.
Right.
Okay.
Put it through a prism.
That's how you get a rainbow. Red, orange, yellow, green, blue, indigo,
violet.
Okay. The 7 colors of the spectrum. Okay. Right. If you the way our brain works and the sensors in your retina. Okay. The rods, the cones. Yeah, the rods give you shades of light and intensity. The cones disentangle color.
Okay.
Okay. And you have an RGB cones.
Nice.
Okay, so we get RGB from.
Right.
You've heard that in computers and
right.
the computer screens and everything. Okay. So now here's what happens. White light comes down from the sun.
Is that what it does?
The particles in the atmosphere, some of them are about the same size as the wavelength of blue light.
Sweet.
All right. Now, if you have a particle and light, and there's a particle the same size as that light, it'll reflect.
That's right.
Or scatter. That's the proper word. Okay. Bounce, scatter, and so that light doesn't make it straight through. It sends in every other direction.
Oh.
So the light from the sun is selectively has the blue removed on its way down to Earth's surface. And the blue scatters into the air. And you have a blue sky.
That's very romantic.
It is beautiful. Now it's called Rayleigh scattering. A guy named Rayleigh.
Rayleigh scattering.
Rayleigh. Okay? Lord Rayleigh.
Of course, Lord Rayleigh. Indeed.
You figured this stuff out. You a lord.
Right.
All right. So here's the thing. As the sun gets lower in the atmosphere,
Right.
the path length of the light is much longer through the air. Okay? So in other words, so here's your atmosphere. If you're directly above, you're going through like this thickness. As you come down, the thickness gets more.
Right.
Okay?
Right.
Well, more atmosphere, more scattering.
Right.
The sky gets more blue. Okay? So in the daytime, it's, quote, sky blue. That's actually a pale blue.
Right, it's a very pale blue.
As you go to twilight, that sucker gets deep.
Yeah.
It gets deep blue. And so much more blue gets taken out of the sun.
I just love how violent deep blue is.
It's deep. And if you take out that much blue, the sun ain't got no blue light left at all. So what color is it going to turn?
Kind of red.
Kind of red.
Kind of red.
Kind of red, amber.
Yeah.
Okay? That's why sunsets are red.
Oh, that's
Because so much blue was taken out.
Right.
That's all it has left to give you is the side of the spectrum where you have red, orange, yellow. Now, sometimes you have a very bright sunset that's not quite deep red. Aren't many particles there for that sunset. Aren't many particles.
sweet. Nice.
Now, it's also why you can't see stars in the daytime other than the sun.
Well, wouldn't
It's not, oh, you can't see stars in the daytime because the sun is out.
Hey!
That's not why.
Because the sun is brighter than the starlight that you would otherwise see.
No, that's not why.
Well, see, that's intuitive.
No.
That's how you would think.
It's intuitive, but it's wrong. Okay? The reason why you can't see stars in the daytime is because the scattered blue light has rendered our atmosphere aglow.
Nice.
The atmosphere is glowing blue light. And that prevents you from seeing the stars behind it. If you took away the atmosphere,
You'd be able to look up and see the sun.
the sun will be there, but then you like dark adjust over here, and there's full sky, full stars right over here.
Wow.
Over there, all around.
Oh, man. You know what?
What?
if we didn't need atmosphere, I'd want to get rid of it. That kind of sucks.
Okay, so now, this is what led to the operational definition of the edge of the atmosphere.
Okay.
Okay? It's kind of operational. It is, how high up in the air do you have to go before there aren't so many air molecules above you for the blue light to scatter and prevent you from seeing the night sky?
So it's really about the number of particles?
Yes.
It's not
the density of
about
particles.
the actual...
No, it's just the density of particles, wherever that happens. So we agree, just by convention, if you go up 100 kilometers,
Okay.
converted, it gets 62 miles. 100 kilometers, that's about where the atmosphere is thinned out, so that it's no longer scattering blue light. It is no longer a glow, and in broad daylight, you can see stars in the nighttime sky. So that's the operational definition of space.
The operational definition of space is 62 miles above our ground.
Earth's surface, correct.
The surface, where you can just see space, basically.
Because the atmosphere,
the
that
atmosphere
remains, there's still atmosphere there, but it's not dense enough to scatter blue light and render it a glow to prevent you from seeing the night sky. Now, I'm not comfortable with that. I understand it.
Okay.
I'm not comfortable.
Now, what's your problem with that?
Because if the atmosphere were half as thick as it is,
Well, then it would only be 30.
it would be 31 miles. That would be space. Well, suppose we're a tenth of it. Then it would be 3 miles. Suppose we didn't have an atmosphere. You'd be in space just standing here, sitting here like this. You
So
might
what would your operational definition of space be if it is not indeed this particular
Either in-
atmospheric link?
Thank you. If you take out the atmosphere, either you're in orbit or you're going somewhere. Then you're in space.
Oh, so you're using, oh God, you are such a astrophysicist.
You got a problem with that?
You are using gravity as the measure of what makes space. At least you are consistent. Oh my God,
problem with that?
That is amazing.
And that would be true no matter what atmosphere we had.
I should have known.
What? I'm just saying.
It's like,
Of course.
He's like, no, man, where does gravity fit into this?
Okay.
All right, you talking about
All right.
atmosphere.
So you know how much atmosphere that is? 62 miles. That's high up. I would show you.
All right. Oh my God, you had to break a globe to show us
I
this.
just took it on. This is like God.
that's just a holder.
This is God holding up the globe.
That's
okay?
Atlas. Okay,
That's
there we
right.
go.
Right. Okay. So I'm going to show you. Here's the United States.
Right.
And I just did some distances I know, New York to Boston.
There we are.
That's 200 miles,
don't
okay?
know. Go ahead.
220 miles, no, 180 miles,
All
okay?
right, all right.
So you take a third of that distance,
Okay.
that's 60.
Okay.
Make that go vertically up.
All right.
That's the edge of our atmosphere, 3/8 of an inch up.
3/8 of 1 inch off this is what makes
Is
Oh my God, we're in danger.
so
That is not cool.
Earth's atmosphere is to Earth as the skin of an apple is to an apple.
That's what I'm saying.
We don't have much air.
We are in danger.
That air is frail and fragile.
Oh my God.
And you're doing what to it?
And we're doing all kinds of nasty stuff to it. That is unbelievable. Oh, that's insane.
Oh, so I misspoke. 3/8 of an inch up, that's the altitude of the International Space Station orbiting.
Oh my God. So our atmosphere is actually
Less than
below that.
Yeah, so I'm just looking at here. There's New York and there's Boston. So you're talking a couple of millimeters, about a millimeter above, 2
that's
millimeters.
terrible.
That's the thickness of the air above which we say you entered space.
Why are we not teaching this in school? I mean, seriously. If you ever want to have a true appreciation of just what a delicate balance we live in, that is it right there.
Correct.
Ugh,
Correct.
it's chilling. That's
The
really
skin of
chilling.
an apple is to an apple as the shellac on this globe is to the globe itself.
Ugh.
That is our atmosphere.
Oh my God.
Dude.
Well, there you have it. We're all gonna die.
So that's why the sky is blue.
That's right.
That's why we should look after this little bit of air that we got here on the surface of the earth.
I'm with you.
And it's why Neil thinks space should be defined by gravity, not by what the circumstances of our atmosphere happen to be.
There you go.